Alright guys, here's our project for today. Unit number 3. Thermostat is blank. We have no cooling or heating going on at this location. So, get right there. I'm going to take a wild guess that this is our number 3 breaker. So I'm going to get up on the roof, flip that disconnect down on the unit, and then I'll come back, reset this, and then we'll troubleshoot that unit. Here we are at the roof. This is our unit that is not working. Kind of see the model and serial number on it. So like I said, before I go down and reset that breaker, I'm going to shut this disconnect off. This way I can flip that breaker and I'll have power at this disconnect. I can come up here and troubleshoot, and if need be, if I find the problem and it's an easy fix, I can just turn my disconnect back on and be all set. Alright, my disconnect is off. The breaker downstairs has been reset. So first, let's just verify incoming power to this disconnect. It's a pretty bright day out here, guys, so I apologize. You probably can't see a whole heck of a lot. I don't know if I can reach that with my leads. Yeah, it looks like I might be able to. Alright, we got 490. $490. And come on, get on there. 493. So we have power. Now we got to figure out what tripped this breaker. Just wanted to make sure it is 463 phase, because you never know. Oh, quick tip, guys. You probably already know this, but on these carrier units, a lot of times, if that data tag is gone, they'll have a little sticker inside here with your model and serial number. Alright, so first, visual inspection. I don't see anything obvious. Nothing burned through. No obvious arcing. Transformer hasn't caught on fire. Board looks good. Contactors look good. No loose terminals on my contactor. Capacitor, it's not all puffy, so that looks good. Check down here. Really, I'm just checking for rub-throughs. Anything obvious, you know. Any place where wiring touches metal, that's alright. It's not rubbed through. But see this wiring right here, how it's all floppy like that? We'll have to address that. We'll find a way to tie it up and keep it from rubbing on everything else. There's a compressor. We'll get around to the other side, pull that panel off, and check that compressor in a minute. What I'm going to do, though, before I do that, is I'm going to check this contactor. Because these are the wires that go to that compressor, so I'm just going to check there first to ground. So nothing over there looks obvious. Let's check here. Our blower compartment. All our wiring looks nice and tight. It's kind of hard to see back there because the sun is so bright out here, but everything looks good. Yeah, I don't see anything obvious. So let me get my meter out and start checking some components to ground, see if maybe we got something shorted out. Alright, I got my meter all set up. One lead is attached to the ground, and with my other lead I'm just going to check the various components to ground and see if we have any continuity anywhere. I'm just doing it at the controls first, and then I'll go to each individual component and I'll check those to ground as well. So far, nothing on my contactor. My switching relay, nothing right there. Nothing. Nothing. Capacitor, nothing. Let's check our transformer. Nothing. Nothing. Check the chassis. We're still grounded. Now, if you notice, our low voltage side all have continuity to ground. Now, that still is somewhat confusing for me, but I was always told the reason why our 24 volt will always have continuous ground, or will always be grounded, is just for safety. For example, on this transformer right here, we have 460 on our primary side and 24 volts on our secondary side. And from what I understood from the old guy who taught me, is that we ground it for safety, just in case like this shorts out, or just in case we have a direct short from our primary to our secondary, then our ground will be right there and it'll trip our breaker before anybody gets hurt. Again, I'm not an electrician. I have looked into that subject a little bit, and really everything always goes back to safety for the most part that I've found. But if anybody out there knows a little bit more than I do, let me know. Put it in the comments. So anyway, no shorts to ground over here, so I'm gonna pull that panel off the compressor over there, double check that, and then we'll also double check our blower motor as well. All right. Here's our compressor, guys. I got one lead just attached to the bolt, which goes to ground. If you listen, I am grounded at my copper line. Now that's all right to be grounded right there, but we're gonna check right here. Nothing. Kind of scratch it a little bit, make sure I'm getting good contact. And I got nothing. Well, my compressor's not grounded. Let's get over to our blower motor then. Alright guys, as you can tell, I got the side panel pulled off to expose our blower motor. I prefer to do it this way rather than try to pull it out the front, try to unmount that motor and pull it out the front, inspect the wiring. It's just easier this way. Plus, I can inspect my heat exchanger while I'm at it, which is getting pretty bad. You can probably get maybe another year out of this if they're lucky. But anyway, into our blower motor here. Try to get you out of the sun. I inspected all of our wiring. Nothing is shorted to ground directly. So our motor seems to be fine. On a side note, what was kind of confusing at first though, I checked this wire to ground and I had continuity. So I thought maybe that was my short to ground that I've been looking for. But if you come down here to our schematic, and let's see, so we look right here on RT, that red wire that we were just looking at comes off of our 24 volt transformer, goes through our overload relay, that's inside of our blower motor, comes out the other side, and then goes into our control board. Now, because it's low voltage control wiring, it is grounded. So once I figured that out, I knew why we were grounded. So that's not our issue. So at this point, since I don't see an actual ground, I can't find an actual issue, we're just gonna power it on and see if it trips again. Maybe they had a power surge here. So let's turn it on and hopefully sparks don't start flying out of something. Now, since we can't find any shorts to ground, what I'm gonna do is I'm gonna power it on, let it run in cool mode, see if maybe my compressor is drawing locked rotor amps, which could trip my breaker. So I got my amp clamp all set up. I got my thermostat jumpered out to go directly into cool mode with the indoor blower motor running. So let's get to it and see what happens. Compressor is on, pulling 5 amps, which is not bad at all. see, my condenser, 5 points. Actually, that's not my condenser. .7. See if we can get up here to our blower motor. Come on. Go. Blower motor's pulling 1.1. Nothing out of the ordinary. Notice my branded bucket there, my Curious HVAC guy bucket. Anyway, we're cooling, we're running. We haven't tripped a breaker yet. Let's go over here and get a supply temp. Well, not gonna get a supply temp that way. Starting off at 80. Not a whole lot of hot air coming out of there. I know it looks like the condensing motor either isn't spinning or is spinning very slowly, but it is actually spinning. Let's do the old air CFM test on her. See, it's working. That's about 200 CFMs right there. Let's get over here. See if we can grab some lines. See, our discharge line back there is warm. Not as warm as I was thinking it would be, but it's probably about 65, maybe 70 degrees out today. Nice and cool in the store, so probably not getting a whole lot of a load. I'm going to check my return air temperature here in a minute. Alright guys, let's let this run for a little bit. See what happens, alright? Well, I let her run for about 5 minutes. And my supply temp never really dropped. So I pulled this panel off. I found my blower motor isn't turning. And really quick, I double checked all my wiring inside that blower motor just to make sure that I didn't forget to put something back together. And that's all fine. So let's come over here to our relay just to see if we're getting voltage on our blower relay. We do have voltage on our relay, so our relay should be closed. Now we just need to check and verify that we actually have power going to our blower motor. Alright guys, let me set this camera down real quick so I can check that motor. I did verify we have 490 volts sitting on the left side on both of these terminals to the switching relay. But on the other side, I wasn't getting proper voltage. So what I'm going to do is check this relay once I have 24 volts going to it. It's kind of bright out here. But I'm going to check this relay across these two terminals, 4 and 6, and 1 and 3, once I get this thing powered up. For now, I have my call for cooling disconnected. I just have a bypass jumper on my indoor blower motor. So we're gonna fire it up and see if I have continuity across that switching relay. I should. I don't think I do though. I know it's hard to see in there, guys. Alright, I don't have any continuity across this relay. Let's double check our voltage real quick. 26 volts at this relay. So my switching relay isn't closing. So I'm gonna run down to my truck, grab another switching relay. And if you're wondering why my compressor came on, this particular unit is operated by a energy management company. So there probably is a call for cooling downstairs. I just bypassed it when I started just in case there wasn't a call for cooling. And another tip, if you guys ever want to do what I did here, make sure you tape up some of your terminals. Like these ones I wasn't too concerned about, but this one didn't have any plastic insulation on it, so I taped it up to make sure it didn't short to ground. So if you're gonna do experiments like that under voltage, be safe about it, okay? All right, let me go grab a relay and we'll pop it in there and see what happens. We have our new switching relay installed right there. It's a little bit different than the old one. If you'll notice, the new one has a terminal for 2 and 5. Don't be too concerned about that. 2 and 5 is just a normally closed terminal from 1 and 2, and then also from 4 and 5. I don't use that for this particular setup, so we're not gonna do anything with that. But what we are gonna do is I'm gonna power it back on. And I'm gonna check for continuity across my top 2 and my middle 2 terminals. 1 and 5, or excuse me, 1 and 3 should have continuity, and 4 and 6 should have continuity once we power it up. You'll notice we have continuity across our relay now. All right. Let me get this motor wired back up and we'll power it back on, see if that blower turns on now. My relay's all wired up. My amp clamp is set up. Let's power it on and see if that blower comes on. There's our blower. Pulling 1.6 amps. Let's get this cover back on here. I checked the rotation on that. I didn't feel like it was pulling much. Let's see. I believe we're going the right direction, but I just want to be sure. Yep, we are. There's our arrow going that way. All right, we're good. False alarm. Now you'll notice that belt on that blower was kind of loose. I am going to replace that while I'm here. But first I want to make sure everything else is running the way it should. So let's let this go for a little bit, guys. See what our supply temperature turns out to be. And then we'll revisit this in just a few minutes. Just for the heck of it, I decided to pull this switching relay apart. So here's the base of our relay with our solenoid coil on there. And this is the inside of our relay. Let's pull this, see if we can pull this little solenoid right out of there. So there's our little plunger that goes inside there, and you can tell that spring is pretty burned up and melted. But if you look inside there, all of our terminal contacts are melted and destroyed. So my idea of why our breaker tripped is obviously this shorted out internally, and through this plunger, through this spring, which is partially melted, it probably connected one line to the other line, and that's what tripped our breaker. So that's our culprit, guys. That's the gratification we're looking for today. Alright guys, we're wrapping up this call here. That's our unit right there that we were working on. And as you've seen, we had a faulty switching relay that was internally melted, which had caused our breaker to trip. You didn't see it on camera, but I did go ahead and replace that belt with a spare that I had. Our final supply temp was 54, our return was about 76, so we had a good
good 22-degree split on there. The thing I want you to take away from this video is remember to slow down, take your time, check everything over. Granted, I didn't find a major component like a compressor or a motor tripped or shorted to ground rather, but we took our time, made sure everything was safe before we just powered our disconnect back on. Because in this scenario, we had 490 volts, 490 at the disconnect. Yeah, it's a 460 unit, but we had 490 at the disconnect. So something with that much voltage, you really don't want to go turning things on just to see if a breaker pops. You want to take your time, check everything over, make sure it's safe, and then power it back on. So I hope you guys learned something. Hope you enjoy the video. Thanks for watching. I always appreciate you guys watching. I always appreciate the comments. Keep them coming. I do learn quite a bit from the comments. So if you see something, know something, let me know. All right? We'll see you on the next one. All right, guys? Like and subscribe.